So, we have now all been hired at Professional Parabola Productions. Fun story, none of us applied, they just hired us. So, we now have been tasked with, we're kind of on their design team. Okay, so their design team wants to start branching out from the average. So, they have been used to creating parabolas for y equals x squared. They want to start investigating how could we create parabolas that are wider or narrower or shifted right or shifted left or up or down. And if a lot of those things have happened at the same time, so not just a vertical shift, but maybe a vertical shift and a horizontal shift, and maybe a like intensity multiplier has also happened. How can we pull those pieces out and know what each of them did? So it's easy to say, like, okay, if I have x squared, how could we shift it vertically? Sure, plus 1, right? And that will shift our parabola vertically, or minus will shift it vertically as well. So your task is when you end up with a parabola that is in some sort of form like...
Wait, so I have a...
Go ahead. I'm just going to type some random nonsense in here.
The A, like, if it's negative, wouldn't the parabola be, like, upside down? Like, upward and downwards?
Well, that's for you to investigate and figure out.
And I'm guessing that, like, the B value changes it on the X.
Well, that's for you to investigate.
Because if the C value changes it on the y-axis,
oh,
so then the B value would change it on the y-axis. And then the A, whether it's positive or negative, would open up or down. I'm thinking that's what's happening. Because he hasn't done any negative like things, so and all of them are opening upwards. No, but if you have like negative 2x squared, then I'm pretty sure it opens downwards. And all of his are positive, and they're all opening upwards, so I'm guessing that's what's happening.
Alright, so you guys need to try to investigate all... Well, I mean, you can make your own situations. I just made up random things to go here, so you can make this say whatever you want.
Can we maybe change the black one to negative instead of the black and red being the same?
Sure.
So negative makes it open down. And positive
So, on this... Oh, by the way, don't lose this packet I gave you. It's all of the resource pages for the whole chapter. Make my life easy. Don't lose this. I literally only have one extra. It's mine. Because I don't like making wasted copies. I don't make extra shared class. If you come to me and you need one, I'll print it. So, on here, you should be able to talk about 4 different manipulations of the parabola. So you could go ahead and put x squared plus 2, like... Or sorry, my bad. To make the graph of x squared move upward or move vertically, our first one that we're writing here, move vertically, you can add or subtract a constant, right? So we're not adding or subtracting an x value because when you guys said, like, add or subtract 2, so if I add 2, great, it pushes me up. But 2x does not. Look at this. 2 being added versus 2x being added. That's awkward.
So the B value moves it both horizontally.
Yeah, but is there a way that we can formalize how to, like, take a quadratic given to us and figure out where's its vertex, what its behavior, what's it going to look like without just plugging in a calculator? Is there a way for us to figure this out? I want you guys to spend the next 5 minutes investigating. I really am going to try to resist the urge to talk with you. 5 minutes.
So the C value just makes it go like vertically up and down instead of
And the A value, if it's positive, it opens up. If it's negative, it opens down.
A value is like
The A value is the x squared.
Yeah.
and then
B value is 1 with x.
The B value is the one we're gonna have to
the B value
investigate.
moves it side to side.
I'm going to keep putting things in here, but you guys have your graphing calculators you can play with.
Only the ones that don't have B values.
How many can I put on this graph?
Okay, there's only so many colors, so this will start to become a thing.
How many
Yeah, we're out of colors. So I'm gonna make our basic parabola a dotted line because now we're kind of out of colors.
Oh, it's the weird.
There's a weird like half two parabolas. Or like two different parabolas.
Mr. Hudson, can we see what would happen if you raised x to a power that wasn't 2?
Yeah, just
Sure, that's not what we're doing, but sure.
makes the slope insane.
What about?
Wait, let's see.
So if I turn
Wait, what about
all
if
of
it's a
these
negative
off,
exponent?
I shall leave x squared there. This is x squared compared to x cubed. Because remember, cube roots do have negatives.
What happens?
Square roots don't, so all of the range, remember domain versus range, all of the range values here have to be positive versus my cube can also be negative.
What about a negative exponent?
A negative exponent?
Oh,
what the? Probably just gonna be like another two.
oh, what?
It's just like a.
Goes up on both sides instead of.
Why is
So
the
it doesn't actually
why is
count.
2 like higher than 4?
No.
Oh no, because decimals.
Oh. It's like when I try to draw a straight line.
I'm done with you parabolas.
Those are my problems.
I don't like
What happens if you do like a?
We're not doing powers other than 2 right now.
I know, but
You're
it's
gonna
interesting.
confuse yourself if you try to.
Squared parabola got squished
Wait,
at the
when
bottom.
are we gonna work with
Later.
like later this year or next year?
Yeah, mainly next year, but hey, it's still not 5 minutes and you guys keep talking to me and I can't resist.
Alright, so the A value is just like the slope, I guess.
No, a value is to make the graph of y equals x squared negative. Like,
Why did you make that blue one dotted? Just because you.
Just there's another blue one.
So yeah, if it's negative, then it goes down.
so wait, will we say to make the graph of y equals x squared negative? You
Ah,
can't
they
make
all disappeared. I just wanted to zoom.
Do we reduce? Right, got it.
I'm trying to not interact with you right now.
Should we do anything on
Do we
this?
write to make the graph of y equals x squared
You can't
If you formalize some rules,
negative?
I'm trying to wait 2 more minutes.
If you want to make it negative, you make the a value.
The purple function up here should tell you a lot.
Ooh, it's
You can change the C value for vertically. You can write that in.
Plus.
oh, the C value is one of the things. It says the C value is -4 and one of the points.
Yeah, C value.
As something might be a coincidence.
No, to move vertically, you can change the C value.
That's what we said, right? No, we said to move vertically, add or subtract the
Ew,
constant,
wait.
right?
So,
Yeah, that's what we said.
so on the y value of the point of the vertex, so like if you look at blue, it's 2, and it's 2 on the blue one. And if you look at the equation for purple, it's -4. And if you look at the vertex of the purple, -4, it's -4.
Hmm.
It's okay. You give us
So wait, if I
okay.
take
Sophia,
this off, if I only copy this part, let's make that the black. What's the difference between black and purple?
black is on the x-axis. It
Okay,
doesn't have a
compare
C
purple
value.
to black.
I've heard some of the drawings from
What's purple compared to black?
It doesn't have like the C value that's added to it, so it's
Right, but when we look at the graphs, when we
I don't
visual,
think that
hey, having 3 conversations at the same time is not helpful because we only have 8 minutes left and we're trying to get you out of here for lunch. Purple has been shifted 4 down compared to the black. Right, so what if we take away this and do it to both. Okay, they widen back out. But what could you say about this?
That's how far over it goes.
So we already said to shift vertically, we add a constant onto the end of our function, right, our equation. But to shift horizontally, on the second one, you should say to shift your parabola vertically. So to make the graph of y equals x squared shift horizontally, or left, right, we're still going to, you can, add a constant, but it's inside with the x. Look at the difference between this, let's make this plus 5. That plus 5 shifts it up 5. Right? This blue's up 5. Plus 5 out here shifts it up. But plus 5 in here, that shifted it left. And guys, we should be writing examples. So, before the square happens. So it's in with the value being squared. So we, if you want to, this is how I've always thought about it. It is modifying the input. The plus 5 is modifying the input. This plus 5, sorry, they're doing the crazy lab over there. This plus 5 is actually modifying the output. Because your input is x squared, but your output is the y equals, right? So we're saying y equals the thing with the input, but then add 5. We're modifying the output here. This is modifying the input. And here's the crazy cool thing about the rule. It's just the opposite. A plus 5 in here shifted us left 5. A minus 5 in there.
The orange one was plus 2, so then it was shifted.
Oh yeah.
Because of the x has to be negative. Yeah.
Oh, wait, what? Who, huh?
Because the counter that negative.
Because this then becomes, this is telling us where the x-intercept is. So if I have minus 5, remember, what is the x value if this is our function? Well, x would have to be positive 5 to be our 0.
So then it
Remember when I kept forcing you guys to think about how do we solve these quadratics the most efficient way possible? What if you have a quadratic like this? Zero product property, right? This is zero product. What are your zeros there? 3 and 4, positive 3 and positive 4, right? Boom, boom. So, okay. So both of it, but if we only had one of those and then squared, it would shift us. So wait, this shifts us right to 3, but also right to 4. So when we modify the input twice, it's telling us 2 different ending locations. I will end on 3 and end on 4. Like literally, I have, these are like input-output values, right? So I have the same output at 2 different inputs, right? So literally, anything that has happened in with the input is telling us an intercept. Like this, intercept of 5. This, well, now it's not intercept because this not only shifted left, but now it shifted down. So these get a bit messy. We will later figure out how exactly we get to here and here with the negative 3 and the 7. But if we applied that, like the 3 that we had on here, what's that do?
It makes it how much it opens.
We call that stretch / compression. So to make the graph of y equals x squared stretch / compress, that's what you want to put there because that's really mathematically what we call them. So on the first line, stretch / compress, you can, what is that 3? It's going to, that 3 against the parentheses. So let add, subtract, multiply, divide. It's a multiplier. So say we can insert or add or whatever. I don't like the word add because we're putting in a multiplier. But we can insert a multiplier, in front of our input. Now wait, what if I put one in here? Whoa. So not in the parentheses, right? If you look up, you'll see what I mean.
It's push and move.
Yeah, that does a whole lot of something.
Wait, you can do what to this?
We
So
put a
adding one thing to make it
multiplier
equal.
in front of everything else. So it doesn't really matter what else is after it. Say like right here. If I put this in parentheses, and I put a multiplier in front of all of it, now that also bumped down because remember there's a different B value and a different C value in there. So that 3 will actually impact the other values that have happened.
What's the other first one that we supposed to
I mean, the parent function is this, then we shifted vertically, right, vertically or horizontally. So that was the first one we wrote down, was the vertically horizontally. Or, sorry, not vertically horizontally, up, down, vertically, that's it. Then we wrote down horizontal. But man, so we have vertical is the first, horizontal is the second, stretch, compress is the third. What if it all happens at once? Like our green parabola here.
Parabola just goes,
Man. X squared plus 6x plus 8. Can anyone think of another form of that parabola? Like another way to write that quadratic?
Oh yeah, because X times X is X.
But then
Wouldn't
the
he-
eight
Would that work?
Is that just the same thing as the
Yeah.
last one?
That's the same thing, right? So wait, we took this. What did we say this plus 4 and this plus 2 are going to do? They change the intercepts, right? You guys earlier said they change our x-intercepts. So this is really hard to tell what's happening, but this seems to be a bit easier. These are the same thing, but the factored form seems to be a bit easier.
Factor them first.
So what then, if I go back to something like this, and I ask you to define every piece in the function and what it is doing. What is the 3 doing?
It's stretching, flashing, or compressing.
Yeah, now let's talk about whether it is stretch or compress. I'm going to bring this down to where we can see it. So this 3, if I turn it to a 1, right, it gets wider. 3 gets narrow. So a number, hey, hold up. Give me like 1 more minute. A number bigger than 1 compresses. A number less than 1 stretches. So a number bigger than 1 compresses. A number less than 1 stretches. Then, this minus 5 is what shift? Horizontal. Right? Then the minus 3 outside is vertical. So we will pick this up here tomorrow, and we're going to move fast through some parabola work because we've already done a lot with this stuff this year. All we need to do is formalize how do we pick apart when we're given like a trinomial. How do we then just kind of pull the pieces out and say, oh, this will do this, that, this, and here's my parabola. There's a lot. So, of course, we did not get all the way through the lesson today. We only had 20 minutes. So we will pick this up tomorrow. If I'm silly and I forget, remind me that we need to pick back up in 912, and then we'll go from there. David, you can leave. Goodbye, guys. David's like at the door, just totally like at the starting line, ready to go.